We have an annual historical lecture at Harvard, and usually it's necessary to twist somebody's arm to give it. Since I had just stopped teaching courses, my arm was the next to be twisted. And the question was, what is one going to say about history? Well, it occurred to me that I had had the experience of actually living through a bit of it and could try to collect some of the material and describe it on that occasion last spring. And I started gathering material and discovered that it was amazingly difficult to find photographic material of any sort that wasn't thoroughly familiar. And the reason is, of course, the security surrounding the project at Los Alamos. There was any number of professional photographers there who were instructed to record things that were secret, but there was no effort whatever to record what was going on outside the secret area. And in fact, we all had cameras there, but those cameras were all impounded when we went there. So there is a great absence of human interest material from that period. I thought I would try and put together what I could of this sort of material, but it remains to be seen. You'll see what sort of thing I had to put up with. To tell the story of the nuclear project, let me just remind you of a few things. The neutron was pretty new in the world. There were no neutrons before about 1931, and the investigation of what neutrons do didn't take place instantly as it would these days. It was very difficult finding sources of neutrons. Radioactive heavy elements, radium, beryllium sources and things of the sort were used in those days. The neutrons came out at pretty high energies, hundreds of kilovolts or millions of electron volts. Some of the early work, quite a bit of it, was done by a poverty-stricken group in Rome around Enrico Fermi, who was really rather clever about these things, but they discovered some amazing things. First of all, neutrons enter nuclei pretty freely. They induce reactions. They were investigating that sort of thing, and they would have a neutron source on the table and try to discover what activity was being induced in whatever element they were exposing to their source. One of their earliest discoveries was one of the most puzzling. They had started doing these experiments on marble-top tables when, for some reason, they had to switch to a wooden table. All of a sudden, the nuclear activity was vastly greater. Now, nuclei are very stable things ordinarily. They understood that only high energies are usually involved. But Fermi came up with a very quick understanding of this paradox, that the wooden top tables gave them much more radioactivity, induced radioactivity, than the marble top tables. The reason would be that these wooden tables consist of organic materials, which are mostly lighter elements. A great deal of hydrogen and quite a bit of carbon make up wood. The lighter elements, when neutrons collide with them, take up more energy and thereby slow down the neutrons. Slowed down neutrons were vastly more effective than fast neutrons in inducing reactions. That was Fermi's first discovery, and it's fair, I think, to say that he got the Nobel Prize for that, but one of the many discoveries he made this way was that when you do this, slowing down the neutrons using the ideal medium was paraffin, he got, when exposing the heavier elements like uranium to the neutrons, which were not in any collimated beam, by the way, they were just coming out from the source, all over the place. He found that there were various activities that were being induced, and it seemed to be a pretty good guess that these were transuranic elements. The transuranic elements were one of the elements, one of the essences by which Fermi received the Nobel Prize. I think it was in 1938. And it was the means by which he and his family, his wife was Jewish, could escape Italy at that time and come to America. He went to New York, to Columbia. One of the German radiochemists, it was a new sort of profession, Otto Hahn, was very puzzled by some of these discoveries. Among the many activities which were induced by exposing uranium to these neutrons, there were not only many different radioactivities, but many of these elements had the same lifetimes emitting the same particles as elements that were around the middle of the atomic table. That made no sense at all. He was terribly puzzled by it. The solution came only in 1939 from Otto Frisch and his aunt. What was her name? You probably know it. What's that?
Lisa Meitner.
Lisa Meitner, yes. She was already in Sweden. They communicated this to Niels Bohr, and it occurred to Bohr immediately. He felt like a fool for not having guessed that, in fact, fission was taking place. He had a liquid drop theory of the behavior, particularly of the heavier elements, and what was happening was that surface oscillations were being set up that were so violent that, in fact, the uranium nucleus was splitting approximately in half. Since 1/2 of a heavy nucleus involved too great an excess of neutrons to represent a nucleus in the middle of the table, there had to be not only radioactive emissions from these fission fragments, what they became known as, there had to be neutrons emitted as well. And several people thought immediately that if indeed there are neutrons emitted, and if it was a neutron that started this fission process, that there could be a chain reaction. That was already several months before the war began, on my birthday, my 14th birthday, in September 1st, 1939. This thought about a possible chain reaction really fascinated several people. They began writing about it, but one saw that writing only very briefly. I was following the science columns in the newspapers and noticed how quickly these thoughts, these speculations were extinguished. It wasn't clear whether it had been demonstrated by somebody to be totally impossible. One simply heard nothing more. Well, I went off to become a freshman. Within a few months, the war had involved America through the attack on Pearl Harbor. And the US, of course, had been preparing for some months earlier and had been supplying Britain. Britain went through a terrible ordeal in the year or two following. The Great Battle of Britain was one enormous raid after another over London and the closer British cities. The British theorists were certainly inspired to think much harder about this possibility than they might otherwise have done. And there were several of them began putting together what they called the Uranium Project, thinking about this very seriously, and much more seriously than was going on in America. America had very little involvement. Informed of these possibilities and warned about them, as you'll see shortly, warned about them at some length. America began simply appointing committees. And there was one committee after another that studied this problem over the next couple of years. This, I have to tell you, it was a source of much regret later on. This period of a couple of years, had it been spent constructively instead of simply constructing committees, one to follow another, this could have ended the war 2 years earlier, and it could have changed the nature of the war with Japan entirely. That never happened, but quite a bit did happen. Now, I'm not going to talk about the bomb itself very much, or about the various international questions that arose very quickly. I'll try and talk about my own experiences, how I saw it all, and in that sense, these are just personal recollections. The universities in America at that time began accelerating their programs. My freshman year was a pretty normal one in 1941, but the university decided to accelerate. They began announcing that they were going to give up the advanced courses, since the professors who could teach them were all going into war projects. So I began skipping the intermediate courses and taking the advanced courses, and by the time I was 18, on my 18th birthday, I had had what amounted to most of a graduate education. 2 years of graduate courses was a normal thing, and I had had 2 years of graduate courses by that time. Well, what does one do? I was given a job teaching while I was still an undergraduate. I did a bit of that. The draft board wasn't buying any of that by way of deferment. I wrote a letter to something called the National Roster of Scientific Personnel. I think you've turned off the projector.
No, the computer just went to sleep. Just click on it.
Oh. Oh, okay. Fine, thanks. So this was in September of 1943. There was something called the National Roster of Scientific Personnel. People who had had any training in science that amounted to anything had become quite scarce. They were by that time pretty well caught up in war projects of different sorts, mostly having to do with radar, which certainly was a very important element in the war. I found that in response to my postcard questionnaire that I had filled out, a man came to the university. He was dressed in a dark gray suit, had quite a mysterious look about him. He seemed to know who I was when I encountered him in the hall. That turned out to be because there were photographs of all the students hanging up near the office. He drew me aside into a darkened room that was only used for faculty meetings in those days, and there weren't any faculty meetings. So there were moths fluttering about. we sat in this dimly lit room, and he told me that there was a place that could use my talents. I don't know what talents I was asking. He says, it doesn't make any difference. We need everybody so badly. He had me fill out what would have been a very lengthy security questionnaire, except I had no past to speak of at all, so it was easy for me. I filled this out and then heard no more for a couple of weeks, went on with my teaching and life as a student, such as it was, and all of a sudden heard that I had passed the security examination, such as it was then, and was given the instruction to send my things off. Well, I'll show you how and where, but meanwhile, let me start showing you some of the things. This is a professor I never set eyes on, Kenneth Bainbridge. But by his very absence, I guessed, and part of what I'm going to try and describe to you is the sort of guesswork that we went through. What has happened? Well, there he is anyway. There is Ken Bainbridge next to his cyclotron. One thing I knew was the Harvard cyclotron had disappeared. Well, it had done something more than disappear, I heard. And of course, I was, at this point, trying to put my ear to the ground to find out what in the world was going on. Something called the St. Louis Medical Depot had come to collect the Harvard cyclotron. Well, the Professor Bridgman, whom you see on the right, well, the far right, was an older member of the department, not really doing any war work at this stage. He was just about retired. The story was that he wouldn't mind seeing that cyclotron go off to Oppenheimer's crew, but he was darned if he wanted to see it go to any St. Louis Medical Depot. That's the story I heard. Again, many of the stories one heard were simply false. This photo, I think, shows that it's false. The man in the middle is Robert Wilson, who became the director of the cyclotron lab at Los Alamos, who was later director of the nuclear labs at Cornell, and then finally the great central laboratory in Chicago. Well, there they were arranging to take the cyclotron apart and ship it out there. But the involvement of Wilson was something unknown to me, and it was rather a surprise when we took this photo out of the file. Well, where were we to send our things? It didn't make any difference what you were sending. In my case, it was just a trunk sent by Railway Express, but I was instructed to send it to Post Office Box 1663, Santa Fe, New Mexico. There were various people being approached in the assembly project who were sending whole households of furniture and the families with them. The whole business, wherever they came from, they were told to send everything to Post Office Box 1663. Well, when I eventually got there, I went to the post office to try and see if there was a Post Office Box 1663. I couldn't find any, but I got in a lot of trouble for trying to make that inquiry. I discovered the security people, Santa Fe was full of them, did pick up my curiosity about that post office box. That was just a pseudonym, if you like, for the entire project, as it was located near Santa Fe. Well, I was instructed presently to take a train to the La Salle Street Station in Chicago, call a phone number. Somebody would appear with a ticket that would take me the rest of the way, wherever it was to be. And of course, nobody knew what the ground rules were for revelation. So in principle, I didn't know that I was going to New Mexico at all as far as the guy who handed me the ticket was concerned. But indeed, I had to get on a train and get off at Lamy, New Mexico, which is about 15, 20 miles from Santa Fe, and as close as the Santa Fe Railroad ever gets to Santa Fe. And when I got there, there was a man who got off the train at the same time. He was wearing a derby and a dark overcoat, a sort of short man. He introduced himself as Mr. Newman, and we were being met by a tall, lanky guy wearing dungarees and literally a 10-gallon hat and a cowboy checked shirt. I had seen for the first time in my life all sorts of strange things getting on the Santa Fe Railroad. The name Fred Harvey probably doesn't mean much to you these days, but every other thing on the Santa Fe Railroad was named after Fred Harvey, who established a whole chain of restaurants and hostelries of all sorts along there. I thought, sure, after seeing many Indians get on the train with blankets and whatnot that were clearly Fred Harvey Indians, I thought we were being met by a Fred Harvey cowboy. This chap, I didn't recognize him at all. We drove the 15 miles or so to Santa Fe, and there they had a permanent office in a very secluded patio. One had to sign up to make the journey up the hill. This cowboy turned out to be a cowboy chauffeur, and you'll see it was something more than that. A conversation began, which is unlike any conversation I have ever heard, between the cowboy and this Mr. Newman, who turned out to be John von Neumann from the Institute for Advanced Study, and who was, in fact, America's reigning expert at that time on blast and detonation waves. I had heard of him only in connection with his text on quantum mechanics. We drove north and were supposed to cross the Rio Grande River, which runs north-south there. That's it. We couldn't, in fact, do that because the bridge was out. This is a more modern bridge that didn't exist in my day. This modern bridge. There is the old bridge which was washed out and which we couldn't use. We had to drive north to Espanola and then back south again through the most fantastic country I had ever driven through, or been driven through, sitting there in the back seat of the car. There's a sort of quite a precipitous road, in fact, which goes up toward the top of the Mesa, which Los Alamos sat on. This is the sort of view one had looking back. There was the most unworldly conversation going on between von Neumann and the Fred Harvey cowboy. Von Neumann asked how things were going, and the cowboy explains not very well. What's happening? Well, matter is being annihilated. Matter being annihilated? There's more geography as we were driving up there. Yeah, he said, the world lines are intersecting. The world lines are intersecting. Well, what? This conversation went on for about half an hour, and it may as well try and abbreviate it. I can't remember all the details. But the Fred Harvey cowboy was a mathematician, affecting cowboy dress, which was what many mathematicians did in that part of the world. And, they were describing a failed calculation. One of the earliest calculations, they did not know how to do calculations with converging shock waves involved in something called the implosion, which I can tell you about bit later. They were trying to do these calculations on desktop calculators. The calculations had no intrinsic stability and were going literally crazy and producing nonsense. And these two chaps were discussing the nonsense in mathematical terms, involving all sorts of things that I knew to be absolutely impossible. Well, not only were they impossible, they were completely nonsense, mathematical nonsense, that they were trying to describe one to the other. That was quite an introduction to this strange place. Well, we eventually got to the front gate. That was it, as it stood at the time. But there was a vast amount of traffic presently that went in and out of that particular gate. There were hundreds of employees from the local Indian reservations. The people who lived closest by were in several Pueblo tribal groupings. They were, many of them, employees for the manual work on the project. And there were already a couple of hundred scientists there. This is not what you saw at that time. This is what you saw by about 2 years later, when there had been construction of all sorts. The technical area, such as it was, had been very much smaller than this. It outgrew itself. The building housing the theorists at that time was now a new building, this one over on the right. Secrecy had to be preserved by going from one building to another in these covered passages. The place had grown beyond all bounds simply on this Mesa top. There was no prior planning that went into this. It was chosen because it was a secluded site and never imagined to involve anything of this degree of complication. And the complications, of course, were only to grow. This is the way some families, this would have been a 4-family house up on the Mesa top. That was relatively good construction in the early days. This is what it got to look like after a time, but that, incidentally, that picture must have been taken at a time of a forest fire nearby. This was a women's dormitory up on the Mesa top. That's what a dormitory room looked like. It wasn't mine. My camera was impounded. I don't know who took this illegal picture. There were quite a few soldiers there by this time. A huge military police unit that patrolled everything, and then lots of more or less random draftees who were called the SEDs, the Special Expeditionary Force. I think that was the title. They were people who had some sort of technical training, but the draft boards didn't know very much about technical training, and fortunately they decided that some people whose technical training was having gone to barber school, a couple of those people were finally sent and made it possible to actually get a haircut in the place. I mention that because Robert Wilson, whose picture you saw earlier in the cyclotron group, they started giving one another haircuts, and then as part of the technical procurement for the project, they ordered for the cyclotron a barber chair. And that was delivered. And so after about half a year's delay, we had a barber shop there. Well, oh, this is Bathtub Row. This was the housing that came from faculty quarters of the original ranch school that was there. The site on the Mesa top was one that had been seen on a pack trip by Oppenheimer and friends. It looked like an ideal kind of isolation. Indeed, the school had some number of boys who were all, the whole school was dispossessed, of course, when the project was begun in early 1943. Some of the boys had been tubercular, and in fact there was one log building in which the boys slept in in rooms with no windows, just screens separating from the outside. The theory then was that tuberculosis is best cured by exposure to the elements. That building didn't last very long once the project was there, but several of the other buildings did, and in particular the highest brass in the project, as it in scientific terms, lived in these houses. There were more than 7 or 8 of those houses in the first place. Bathtub row, of course, because those were the only bathtubs in the project. Everybody else had to be satisfied with taking showers. Well, now the people who were there, this is Hans Bethe, who was head of the theory division, and who certainly was one of the pivotal figures in the whole project. He was a man capable of calculating almost anything, immensely versatile. The head of the division that I was in, eventually, because I had had a fair amount of math in my background, I joined the theory group, and I did neutron diffusion calculations for the 2 years of the war, 2 years that remained. Anyway, that was Hans Bethe, and he was certainly one of the principal leaders of the project. This is the badge picture of Oppenheimer. Now, Oppenheimer was not a well-known physicist at the time. I had had, as an undergraduate, really no occasion to learn anything about him, and was amazed to come there and then meet the man. He was quite an extraordinary intellect, immensely versatile, very understanding, and expressed himself in the most literary of terms every time he spoke. In that sense, you've met very few people who were as impressive as he. He wore a sort of pork pie hat, which was very characteristic, and was almost always smoking. He was a devoted teacher, but not an easily understood teacher at all. He expressed himself, generally speaking, in very elliptical terms, and people did have a hard time, but they could always find him wherever he had rested his pork pie hat. When I arrived there, there was an office next to the one I was given. I wasn't given a whole office, a couple of people in a rather small room. There was a larger room next door with the name Edward Teller chalked next to the door. There wasn't the tiniest sign of Teller. Teller had in fact been there and had gone off in a huff because he was not only a very temperamental fellow, but was not given any responsibility for running the theory division. Now the fact is that Teller had already at this stage lost interest in the nuclear, in the uranium bomb, as it were. His interest was in starting up a thermonuclear reaction, a subject he had worked on in the astrophysical connection. He only came back in, I think it was February of 1944. He made some sort of treaty with Oppenheimer, who recognized him as being quite talented and somewhat visionary as well. Wanted him working on the project, but he had no interest in joining Bethe's division, which was the only division really concerned with theory. So he formed a division all his own to deal with what he called the super. And the super was to be the hydrogen bomb, which is rather different in the way it functions. It's a thermonuclear reaction. It's literally a burning process that takes place through the nuclear agency. So that was Teller. Teller finally appeared and was pushing the super and was given a group of his own, including several people who've since become known. There is a somewhat more congenial picture of Teller. There is someone else who had been part of Fermi's group. Fermi was not at that stage at Los Alamos. He didn't really come full-time until about a year later. This is Emilio Segre. Segre had had a great deal of experience with radioactivity as part of Fermi's group. He was given one particular assignment. The very first samples of plutonium were really infinitesimal in quantitative terms, not even the visible amount of the material, but they were able to count spontaneous fission. Now, some fission can take place spontaneously, and of course, if you have a bomb which is already in a supercritical configuration, it won't last if there are any neutrons that enter that configuration of material. So his problem was to look into spontaneous fission and the question of whether spontaneous fission could be a problem, because if indeed any fissions take place spontaneously during the assembly